In this lesson, we are going to talk about factoring by the difference of perfect squares method. You should be in your green note packet on page 23. This is lesson 9.7. The first thing that we're going to talk about is, well, how do you know if we need to factor by a difference of perfect squares? Well, there are three things that you need to keep in mind so that you know that it's a difference of perfect square problem. Number one, it needs to be a binomial. So it needs to be a binomial, which means there's going to be two terms inside parentheses. Number two, it needs to be a subtraction problem. So for it to be the difference of perfect squares, it's going to be a binomial, and the terms are going to be subtracted. The third characteristic is that both terms need to be perfect squares. So we've been talking a lot the past couple weeks about what is a perfect square? What are the first 20 perfect squares? We need to make sure both terms are perfect squares when factoring by the difference of perfect squares method. All three characteristics have to be true when using this method. Okay, so let's go through example 1 and let's use those three characteristics. We need to decide which of the following expressions demonstrate the difference of two squares. So let's look at letter A. Letter A, we have x squared minus 122. So you should start by asking yourself, is this a binomial? Well, yes it is, because there's two terms. So we know it's a binomial. Number two, is this a subtraction problem? It is. There's a subtraction sign right here. Third step, or third characteristic is, are these both perfect squares? X squared is a perfect square because any variable to an even number exponent, if we square root it, it's a perfect square. 122 is not a perfect square because the square root of 122 is not a nice number. There is not a number that we can take and multiply by itself to get 122. Therefore, this problem does not meet all three characteristics of factoring by difference of perfect squares. So that one does not demonstrate difference of perfect squares. Okay, letter B, we have 4x squared minus 169. First question you need to ask yourself is this a binomial? Yes, letter B is a binomial. There's two terms. Second question, is it a subtraction problem? Yep, there's a subtraction sign right here. Third question, is 4x squared a perfect square? It is. The square root of 4 is 2. The square root of x squared is x. And the square root of 169 is 13. So both of those are perfect squares, and it also meets the other two characteristics. Letter B, we would use the factor by difference of perfect squares method to solve for the x-intercepts of our parabola. Okay, let's go to letter C. Letter C, we have x to the 8th minus 5x to the 2nd. So this one, we'll start with our first question. Is this a binomial? It is a binomial. There's two terms. Second question, is it a subtraction problem? It is a subtraction problem. There's a subtraction sign there. Third question, are they both perfect squares? Well, we first need to take out a GCF on this one because they have x squared in common. So let's take out an x squared, and we're left with x to the 6th minus 5. So let's look inside our binomial. X to the 6th is a perfect square. 5 is not a perfect square. Cannot take the square root of 5 and get a nice number. In other words, there is not a number you can take and multiply by itself to get 5. So that one is not a difference of perfect square problem. Okay, letter D, we have x squared minus 24. So we want to ask ourselves first, is this a binomial? It is. Step 2, is this a subtraction problem? It is. Step 3, are both terms difference of perfect squares? In other words, do both terms represent perfect squares? X squared is a perfect square. 24 is not a perfect square. We have 25, which is, because the square root of 25 is 5, but 24 is not a perfect square. Okay, hopefully you understand the difference of how to tell whether something is a difference of perfect square problem or something is not. So what we're going to do in example 2 and example 3 is we are going to factor by the difference of perfect square method. Just like the other two factoring methods, you still want to ask yourself first, is there a GCF? So let's still go through these asking, is there a greatest common factor we have to take out? And then I will show you how to factor by difference of perfect squares. Okay, letter E, we have x squared minus 81. It's a binomial, there's two terms, it's a subtraction problem, and you should be asking yourself, are x squared and 81 both perfect squares? They are. The only thing you can take out of both terms is a 1. So the GCF is a 1, so I'm not going to write it. Since it meets all three characteristics of perfect squares, I want you to draw two binomials. Put a plus in the middle of one, a minus in the middle of the other. And now we need to take the square root of each term. So the first one, when we take the square root of x squared, if you have a variable with an even number exponent, divide the exponent by 2, and that's how you get the square root of it. 2 divided by 2 is 1, so we have x to the first, x to the first. Take the square root of 81, which is 9, write that in the second part of your parentheses. So our answer is x plus 9, x minus 9. If you FOIL this, the middle two terms are going to cancel. And let me show you real quick. X squared minus 9x plus 9x minus 81. So if you FOIL, these middle two terms cancel. You end up with the original problem. So a good way to check is to FOIL the problem to make sure that you end up with the original binomial. Okay, letter F, 4x squared minus 1. So this is a binomial. It's a subtraction problem. And I want you to ask yourself, are both terms perfect squares? Okay, hopefully you figured out and said yes, both terms are perfect squares. So the very first thing you do on a difference of perfect square problem is make two binomials. So let me do this up here. Make two binomials, put 1 plus, put 1 minus, always. It's always how you start the problem. You then need to ask yourself, what is the square root of 4x squared? The square root of 4 is 2. Just like when we memorized our list, you guys should be pretty good with those by now. The square root of x squared has an even number exponent, so divide it by 1. Sorry, divided by 2, we get x. Take the square root of 1, we get 1. So we have 2x plus 1, 2x minus 1. Again, if we FOIL, the middle terms will cancel, so you end up with the original problem, 4x squared minus 1. And that's it. That is completely factored. Remember, we are solving for our x-intercepts of a parabola. Okay, let's do two more in this section. Let's do letter G, and we're going to do one more of these. Okay, letter G, we have 16x squared minus 25. So let's go through our three characteristics. It's a binomial, it's a subtraction problem, and both terms are perfect squares. So once you know all three characteristics are true, make your two binomials, 1 plus, 1 minus, and now we need to take the square root of each term. The square root of 16 is 4, so write that twice. The square root of x squared divide the exponent by 2. It's an even number exponent. 2 divided by 2 is 1. And to double check that, 4x times 4x, think back to chapter 8, is going to be 16x squared. So a good way to check yourself is by multiplying those. Secondly, the square root of 25 is 5. So your answer here is 4x minus 5, 4x plus 5. The order that you write the binomials does not matter. Okay, let's look at letter I. Okay, letter I. First question, is it a binomial? Yes. Is it a subtraction problem? Yes. Are both terms perfect squares? Yes. This one, just like the other three we just did, also does not have a GCF, so we can get right into factoring. So let's make our two binomials, 1 plus, 1 minus, and let's square root each term. The square root of 49 is 7. The square root of x squared, remember, if it's an even number exponent on a variable divided by 2, 2 divided by 2 is 1. The square root of 400 is 20. So we have 7x plus 20, 7x minus 20, and that's our solution that is completely factored. Okay, let's go to example 3. Okay, example 3 is slightly different. We are still factoring completely by the difference of perfect square method. However, when we ask ourselves if there's a GCF, these ones are going to have a greatest common factor. So the process is the exact same. You just need to make sure you are always asking yourself first, what is the GCF? For example, letter K. Yes, it's a binomial. Yes, it's a subtraction problem. But the way letter K is written right now, they are not perfect squares. The reason is there's a greatest common factor we can take out. So let's take out our x to the third, because the most you can take from each term are 3 x's. Okay, so I want you to ask yourself, if we take out 3 x's from each term, what are we left with inside parentheses? Okay, hopefully you wrote down or you were thinking x squared minus 1. If you now look at what's inside these parentheses, x squared and 1 are both perfect squares. So it now meets all 3 characteristics that we've been talking about. Make sure you rewrite your GCF, make your 2 binomials, 1 plus, 1 minus, and then we're going to square root each term. The square root of x squared is x. Remember, 2 divided by 2 is 1. The square root of 1 is 1. This is factored completely. There is not anything else you can do to solve that problem. Keep your GCF in front. Okay, letter L. We have 4x to the 4th minus 25x squared. So again, it's a binomial. It's a subtraction problem. Both terms happen to be perfect squares the way it's written, but there's a GCF that we need to take out first. So let's take out our GCF first. The most you can take from each term are 2 x's. So if we take 2 x's from each term, we are left with 4x squared minus 25. Inside parentheses, there's not anything else they have in common, but we now have a difference of perfect square problem. So you're going to, let me move down here, write your GCF in front, write your 2 binomials, 1 plus, 1 minus, and then we're going to square root each term. The square root of 4x squared is 2x, so write that twice. The square root of 25 is 5, so write that twice. Okay, let's do letter M. Letter M is a binomial. It is a subtraction problem. but both terms are not perfect squares in this one. So you definitely know that you need to take out a GCF first. The greatest common factor in this problem is we can take a 5 from each term. We can also take 4 x's from each term. If that's our GCF, 5x to the 6th divided by 5x to the 4th is x to the 2nd. 125x to the 4th divided by 5x to the 4th is 25. So we're left with, in parentheses, x squared minus 25, which is a difference of perfect square problem. We can rewrite our GCF. Go ahead and make your two binomials, 1 plus, 1 minus, and we need to square root each term. The square root of x squared is x. The square root of 25 is 5. So that is completely factored. That's our answer. We could use that to find the x-intercepts of our parabola. Okay, flip over. Let's take a look at one more of these. Okay, let's take a look at letter N. Letter N, we have negative 4x squared plus 64. So this one, it's a binomial, but now we run into a problem that's not subtraction. It's a plus. However, you should realize that that negative in front on that first term means our GCF is going to have to be negative. Okay, so first thing, just like the other three, we need to take out our GCF. The greatest common factor is negative 4. That's the most you can take from each term. If we take out a negative 4, we are left in parentheses with positive x squared, because negative 4x squared divided by negative 4 is positive 1x squared. 64 divided by negative 4 is negative 16. So once you take out your GCF, we know x squared minus 16 represents difference of perfect squares. So rewrite your GCF, make your two binomials, 1 plus, 1 minus, square root each term. The square root of x squared is x. The square root of 16 is 4. So there's an example of when you need to take out a negative GCF and then factor by difference of perfect squares. Okay, let's do one more. Let's do letter P. Okay, letter P, negative 81x squared plus 121. Very similar to letter N because there's a plus on this one. So the greatest common factor you can take out is a negative 1. If we take out a negative 1, we are left in parentheses with 81x squared minus 121. We now have inside parentheses a binomial. It represents difference of perfect squares because they're both perfect squares, and it's a subtraction problem. So write your GCF in front. We have 1 plus, 1 minus. So now you need to take the square root of each term. The square root of 81x squared is 9x. The square root of 121 is 11. Okay, this concludes the first part of the lesson of factoring by difference of perfect squares. Please keep in mind those 3 characteristics. Okay, and also remember this is another way to solve for x-intercepts of a parabola.